Far beyond everything we can see, physics predicts there may be an exact copy of you watching an exact copy of this video. And that is only the first of 3 parallel universes hiding inside mainstream physics. 3 different theories, 3 completely different multiverses, and none of them was invented for science fiction. The reason parallel universes sound like nonsense is that those 3 ideas usually get blurred into one word, the multiverse. But they come from different theories. They live at completely different scales, and they deserve different verdicts. So take them one at a time, starting with the copy of you. The first multiverse needs only one assumption, that space goes on forever. Last episode ended exactly there. Everything we can see is a finite bubble, and space very likely continues far past its edge, possibly without end. If it truly is endless, something strange becomes unavoidable. Inside any region the size of our observable universe, matter can only be arranged in a finite number of ways. Enormous, but finite. Like a deck of cards, shuffle and deal forever, and eventually a hand you have already seen comes up again. Deal across infinite space, and eventually an entire region repeats. Not something similar, the same arrangement, particle for particle, including the part of it that is you. How far away would your nearest copy be? A famous 2003 estimate by physicist Max Tegmark puts it around 10 to the power of 10 to the 29 meters. That exponent is not 29. It is a 1 with 29 zeros, and the full distance is a 1 followed by that many zeros. If you read the zeros out loud, 1 per second, you would still be reading hundreds of billions of times longer than the universe has existed. This is the tame multiverse. Same laws of physics, same constants, just unreachably far away. And one honest catch: it only works if space really is infinite. Our measurements say space is at least vastly larger than what we see and remarkably flat, consistent with infinite, but not proof. The second multiverse does not come from infinity. It comes from the theory of how our Big Bang began. In the first tiny fraction of a second, space itself is thought to have expanded absurdly fast, a burst called inflation. Cosmologists did not invent inflation to make universes. They use it because it explains real observations, like why the oldest light in the sky looks so evenly smooth in every direction. But in many versions of the theory, inflation has a side effect. It never stops everywhere. It ends in patches, and each patch where it ends becomes its own Big Bang. In this picture, our entire universe is one bubble in a sea that is still inflating, and new bubbles keep forming forever. Bubbles that could have frozen out of inflation differently, different particle masses, different forces. Universes where the rules themselves changed. Unlike the first multiverse, this one comes with something precious, a fingerprint we could actually look for. If another bubble ever collided with ours in the deep past, the impact would leave a bruise, a faint circular disk stamped into the oldest light in the sky, the cosmic microwave background. That is the baby picture of our universe. Radiation released when the cosmos was only a few 100,000 years old, and we have mapped it across the entire sky. So cosmologists searched it. In 2011, a team ran the first dedicated hunt for collision scars in the full sky microwave data. They found no convincing circle. Sharper maps from the Planck satellite followed. Still nothing. That silence does not kill the idea. A collision might never have happened inside our patch, or the mark might be too faint to see. But the one clean signature we know how to search for has not shown up. The third multiverse is not far away at all. If it exists, it is here, in this room. It comes from quantum mechanics, our physics of atoms and particles, and one of the most precisely tested theories humans have ever built. The math of quantum mechanics says a particle can be in a blend of states at once, until you measure it and find just one outcome. The textbook story says the other possibilities simply vanish at that moment. But that vanishing is an extra rule bolted onto the equations, and nothing in the math says it happens. In 1957, a young physicist named Hugh Everett asked the obvious forbidden question: what if we delete that rule and just let the equations run? The answer falls out on its own. Both outcomes happen. The world, the particle, the detector, you, splits into branches that drift apart and can never talk to each other again. Not in some distant galaxy, right here, separated by physics instead of distance. Here is the honest part. The branching version of quantum mechanics makes the same experimental predictions as the textbook version. That is why physicists call it an interpretation, a reading of the same math, and a respected one. But it also means no experiment so far can see another branch. The theory itself says you never could. Which brings us to the closest thing the multiverse has ever had to a news headline. In December 2024, Google announced a quantum chip called Willow. The real achievement was serious. Quantum computers drown in errors, and Willow was the first chip where making the error-correcting system bigger made the errors go down instead of up, a threshold researchers had chased for decades. Google also ran a benchmark task in under 5 minutes that they estimated would take the fastest supercomputer 10 septillion years. Then the founder of Google's quantum lab added a line that went around the world, that this performance lends credence to the idea that quantum computation happens in many parallel universes. Headlines announced that Google had touched the multiverse. It had not. What the chip actually measured was error rates. The parallel universe line is one interpretation, the many worlds reading you just saw, of where a quantum computer's power comes from. Other interpretations predict the exact same chip, running the exact same speed. Most physicists called it what it was: impressive engineering with disputed philosophy stapled on top. So line all three up and grade them like a scientist. Repeating space, forced by simple counting if space is infinite, but its copies live forever beyond our horizon, where no telescope can ever check. Bubble universes, a side effect of our best theory of the early universe, and the one fingerprint we knew how to look for is not there. Quantum branches, what the equations say if nothing ever collapses, and by their own logic, invisible from inside a single branch. 3 serious motivations. 0 confirmed universes. And that is the strange, honest place physics has landed. Nobody set out to predict other universes. They keep falling out anyway. From infinity, from inflation, from quantum math, as side effects of theories we trust for completely different reasons. So far, nature has refused to confirm a single one of them. The multiverse is not settled science, and it is not nonsense. It is what happens when you take our best equations seriously, past the edge of what we can measure. The real open question is whether nature will ever hand us a way to check, a bruise on the sky, or something no one has thought of yet.